Hello, everyone. My name is Aaron Lee. I'm the lead PI for our data generation project. I'm very excited to share with you all what we've done so far and the progress that we've made. As a way of introduction, our data generation project is focused on creating a multidimensional, ethically sourced dataset in diverse people for studying salutogenesis in type 2 diabetes. And salutogenesis can be thought of as being the opposite of pathogenesis in trying to understand how people go from a disease state back to a healthy state. Our data generation project is also referred to as the AI Ready and Equitable Atlas for Diabetes Insights, or AI Ready. And so you'll see our project logo in some of our materials. What are we doing in our data generation project? Well, we are asking approximately 4,000 people to come in for to collect all this information. So folks who are invited to be part of our study would have a pre-visit surveys that they will fill out, and then when they are on site, their visits have been ranging from 3 to 4 hours, where we do all sorts of information that we gather on them, including things like a monofilament test, different forms of retinal imaging, blood tests and urine tests, a 12-lead EKG, cognitive function testing, physical assessments, and then banking of their biospecimens for further research. They are also sent home for 10 days where they are wearing a continuous glucose monitoring device, as well as a fitness tracker to measure activity monitoring, and a custom-built environmental sensor that will measure different pollutant levels as well as spectrum of light inside of their homes. This is our pilot data that we've completed. We have approximately 200 people where we have successfully enrolled them, gathered all of this data, and now are in the process of packaging this information for release later this year. Our project hopes to eventually have even numbers of these first three graphs by the end of the study. So currently this is our breakdown by biologic sex, by race and ethnicity, and then by diabetes group. Right now, this is our distribution as it relates to age at the time of enrollment into our study. We have done a lot of work, not just in collecting all of this information, but trying to make this data as easy to use as possible for downstream analyses. And part of what we have done is to take each of the different domains of data, identify a data standard that would be most appropriate and most widely adopted in the community, and then apply that to the different data sets that we have. And so for things that are related to survey data or cognitive function testing, or things that are similar to what would be found in an electronic health record, we have chosen OMOP as our representational standard. For things that are more like wearable devices, like the fitness tracking device and the continuous glucose monitoring, we have chosen the mHealth standard. For different forms of retinal imaging, we have chosen the DICOM standard. For the 12-lead EKG, we have chosen the WFDB standard. And then finally, for the environmental sensor data that we collect inside of people's homes, we have chosen the Earth Science data specification standard. We have also built a website that can be used to sort of connect the folks who are generating data to the researchers who would be later reusing that data for different forms of analysis. And this is supposed to be sort of an end-to-end life cycle approach to uploading data incrementally, and then standardizing that data using automated pipelines, and then finally generating that data and packaging it for release and sharing downstream. And so this resource is called FairHub, fairhub.io, and it is where we will be hosting our data as it becomes ready for release. This is sort of a schematic that it gives you a picture of what we hope people might be able to do with this data set downstream. There's because of all the different domains of data that we're collecting, we think that there's no shortage of cross-sectional type AI models that could be built, where you take one domain and you try to predict something else that was captured around the same time. We also hope that to enable studying salutogenesis, people will use dimension reduction techniques to assemble these pseudotime manifolds, or that sort of assort people along these spectrums as people go from either healthy to disease or from disease to healthy. And then if these scaffolding is successful, then you can imagine a whole host of predictive AI models that could be used to understand, taking one domain of data and trying to predict some other important health marker. So our accomplishments to date include collecting pilot data on approximately 200 participants. We have already started to engage with these international standards bodies to help them extend their standards to include the extensions that we have created for our data set. And then we have also developed a novel license that we will be using to release our data set that includes many different considerations and discussions that we had as a project, going over things about ethical and transparency use with our data set. So our main study started in December of last year, and our goal is to collect approximately 1,300 participants by the end of year 2. We are transforming the pilot data, as I mentioned, into these different standards and building an automated ETL pipeline that will allow for the clinical centers to upload their data, and all the processing will happen in a fully automated fashion. We're also iterating on FairHub, and we hope to get some community feedback on this as we engage all of you in trying to understand the resources that we have built to make the data set as easy to use as possible. There's many different opportunities for engagement, and so we hope to hear from you. We will have several of our team members be present during the Jamboree to interact with the participants and answer different questions. And we hope to solicit feedback from the community on an ongoing fashion into the future. Just to acknowledge that this is a very large effort across many different institutions and many different disciplines of science, and ranging from bioethics all the way to data science and machine learning. And we would never have gotten here if it wasn't for all the hard work of the project managers, the clinical research coordinators, and the developers that are all part of this project. These are just some references for some of the standards that I mentioned if you're not as familiar with them, and I thank you for your attention.